There's a wonderfully startling implication of time dilation that isn't often as fully emphasized as it might. And I'd like to briefly describe it to you now. It has to do with the following fact. So we know from the formula for gamma that the effects of time dilation only really kick in a significant way when the relative velocity that's being studied in a given situation approaches the speed of light. That's all true. But there is another way in which the effects of time dilation, in which the effects of the relativity of simultaneity, in fact, can be amplified over very large distances. Over very large distances, these effects can become significant even when the speeds involved are ordinary, everyday velocities. So how does this go? Well, to set it up, let's first think about time for a moment from the perspective of experience, right? So we all generally think of time as a kind of continuous unfolding, a continuous flow. But for the purpose at hand, it's useful to also think about time in a different way, as a kind of series of moments, a series of snapshots, one moment after another moment after another moment. And any physical process can, of course, be described in this way. A flower, a wild animal running moment after moment after moment, horse running and so forth. It's just a series of snapshots that capture each subsequent moment in time. In fact, you can even go out into space, if you will, and think about the Earth in its orbit around the sun. Again, moment after moment after moment. Okay, so what I'd like to do is start with that way of thinking about things, and I'd like to compare my set of snapshots, my sequence of events that are unfolding over time, and want to compare my snapshots to somebody else's snapshots who's moving relative to me. And to do that, there's a related idea that I want to introduce, which is the concept of a now slice. And by a now slice, what I mean is I consider the world and I think about all things that are happening right now, like the stroke of 12 on a clock, or at that moment, my cat jumping, or perhaps other events like a bird taking flight at this very moment, say in Venice, or we can go cosmic on this too. So we can imagine at that very moment, a meteor just striking the surface of the moon, or go even further away, we can imagine a supernova explosion way in the far reaches of our galaxy. Now, a now slice is a slice in this picture here where I put down all those events which I say happen at one moment in time. And if I look at one now slice after another, this is the unfolding of one moment after another after another. So each of those events that lie on a given slice constitute those things that I say were real, were happening at a given moment. One now after another now after another now. There are 2 points that I want to stress about this. We give this picture a name that makes perfectly good sense. We call this space-time, right? Because we have all of space in each one of these slices. Imagine the slice goes on forever, includes everything that's out there in the cosmos at a given moment. And along this direction, of course, we have the unfolding of time. So we have space and time. That's where the name comes from. Second point is common sense and everyday experience would tell us that every single observer in the universe, regardless of their motion, should agree on what is on a given now slice. That's the Newtonian view of how the world is put together. But when Einstein comes into the story, that radically changes. Because with Einstein, we have now learned that the constant speed of light means that observers who are in relative motion do not have the same sense of simultaneity. They do not agree on what is happening at a given moment in time. And that has a startling implication that I'd like to describe. And to do that, let me use a little metaphor here. It's one that actually I used in my NOVA program, Fabric of the Cosmos, if you've seen that. But if not, it's a straightforward metaphor. Think about this whole expanse, this whole space-time expanse, as if it's kind of like a big cosmic loaf of bread. And what these now slices are, I'm basically cutting this loaf of space-time into pieces which represent all of space at a single moment in time from my perspective. If someone is moving relative to me, they have a different perspective of what now is, what is simultaneous, and that means they carve up the loaf at a different angle from me. So let me just show you that schematically. So let me imagine I consider the bird's eye view of that picture just because it's easier for me to draw. And let me write down my now slices in there. So from the bird's eye view, I will draw space at one moment of time, space at, say, the next moment in time, the next moment in time, and so forth. So these are all my now slices. And just so that I have these labeled in a way that we all understand, put it down here. Going to the right in this picture is what I consider the future. And going this direction is what I consider the past. Now, somebody is moving relative to me, and let's say they are also interested in drawing space-time slices. So let's draw theirs. And because they're moving relative to me, they will slice up this region of space-time at, say, a different angle relative to me. They slice the loaf with a knife that's angled relative to my slice, because their notion of simultaneity, what's happening at a given moment, say, differs from mine. Now, if we are dealing, and this is the point, if we are dealing with low velocities, the person far away has a low velocity, so we're not talking about velocities near the speed of light. What that translates to in this picture is that the angle that we have here, this angle is relatively small. So in the vicinity of where that person is sitting, low velocity motion has virtually no impact. But the point, and I'll show you an animation of this in a moment, is that over larger and larger distances, let's say I am over here, and let's say somebody else who's doing the moving is far away, over very large distances, a tiny angle can get amplified into a very large difference in time, a very large difference in our conception of what's happening at a given moment. So let's take a look at that idea in animated form. Let's imagine we are looking at a big expanse of space and time, and we have a character, an alien, very, very far away in space, and we have a more familiar looking character, a human being sitting still on a bench over here. Now, if initially these two individuals are not moving relative to one another, they share the same idea of simultaneity if there's no motion, so they slice through the space-time loaf in the same way. They both agree on what's happening at a given moment in time. Okay, but now let's change things a little bit. Let's let our alien friend hop on an alien bicycle, say, and let's say the alien starts to ride away from me. Because of the relative motion between the alien and me, or the guy on the bench, the alien has a different conception of simultaneity, a different notion of what's happening now. And what that means is, when the alien slices up the space-time loaf into all of space at a given moment, the now slice will cut through at a different angle. And again, the point is, small velocity means small angle, but consider a small angle over larger and larger and larger distances between us, and that small angle turns into a big change in time. So in fact, the alien's now slice actually sweeps into the past. And it can be a significant sweeping into the past. When you put in some numbers, as we'll do later on in this course, you find that the sweep goes beyond when that guy was a baby, goes further back in time than that, and in terms of events on Earth that the alien would claim to be happening right now from his perspective, it might be hundreds of years ago. Say, Beethoven putting the final touches on the Fifth Symphony. Now, the thing that's not completely obvious about this and does take some mathematics, and if you're taking the math version of this course, we will do the math. If you're not taking the math version, I hope this is sufficiently exciting that you might take the math version of the course. But putting that to the side, why did it swing to the past and not, say, to the future? Here's a quick way of thinking about it. Remember the treaty signing ceremony. President of Backwardland, right? Backwardland was rushing away, that president, and he signed the treaty late, right? He was not the one who did it first, he did it second, if you recall. So in essence, if you are moving away, you are sweeping to the past. You are old news from that perspective. But that also means, thinking now from the treaty perspective, the president of Forwardland, if you are approaching, if you're going forward, your notion of simultaneity should sweep into the future, and indeed that is the case. So if the alien hops on the bike again, but turns around, say, and doesn't ride away from Earth, but rides toward the Earth, then indeed the alien's notion of what's happening right now on Earth does sweep from what we consider to be the present into what we consider to be the future, and might include strange things from our perspective, like this guy's great-great-great-granddaughter maybe teleporting from one place in the universe to another. So the point is, the whole notion of what you consider to be real, what you consider to be taking place right now, is totally dependent on your emotion, right? So initially, when the alien was not moving, say, relative to us, let's put ourselves in the position of the guy on the bench. From our view, we agree with whatever the alien says is happening right now, whatever's real, we totally agree, right? Now, when the alien gets on a bike, we don't suddenly discount the alien's perspective because he's on a bike. So if the alien then says that other events are considered to be now, to be real on his now slice at a given moment, we should accord that statement the same status, the same believability as when the alien wasn't moving relative to us. So if the alien tells us that things in our distant past are real, they are on his now slice at a given moment, we need to take that into our perspective on what's real. If the alien tells us that things in our future are on his now slice at a given moment, we need to take that into account too. So what this collectively tells us is that the traditional way that we think about reality, the present is real, the past is gone, the future is yet to be, that is without any real basis in physics. What we're really learning from these ideas is that the past, the present, and the future are all equally real.